Hello everyone, my name is Digamos. I'm a self-taught book bounty hunter and a web developer. So today we are going to be talking about HTTP request smuggling. So HTTP request smuggling was first discovered in 2005 and later in 2016 a guy talked about it, but it was just focused on web cache poisoning. And later in 2019 James Katie came with a talk on it, and it really went viral because he really explained a lot about it and how you can dictate it. Okay, so before we move into the video, I'm going to be sharing with you what is actually taking place on this channel. So if you're new on the channel, you should know that if you are a book bounty hunter, you need to know more about a lot of exploit like save aside request forgery, remote code execution, shield upload, XSS, SQL injections, and then you need to know how you can be able to exploit them by yourself. So this is a very good spot for you to start on, because I'm having a talk or videos on each and every type of this attack. Okay, so each and every one of these attacks that I've just mentioned here, there are videos on them with more videos. Like for HTTP request smuggling, is having its own personal video, and what actually is amazing in it, because we explain to you each and everything you need to know about the attack, and then we show you real world exploitation that have been found, and then we try to show you how they were being exploited. Okay, so now secondly, if you are a gambler, okay, meaning that you love to gamble on soccer or what we call football. So actually I personally develop a tool. So what the tool does is take each and every player, okay, in a teams, their last five that's their last five, what they have been performing, how they are performing, each and every player have been performing in their last 5 matches, and then he combines them together. Things that he take notes of is like shot on target, big chances created in the match, key passes, and then okay, so those things like that, there are a lot of things that you take into consideration, like the weather condition of the market, and you sum them all together in order to get, so that we can get the best of the best. Okay, so I must have to tell you that since I started uploading videos about this, I've been able to make about 5% profit, and we all know what 5% profit means in gambling. Okay, so now let's move into the video of today. So HTTP request smuggling. Okay, so what is HTTP request smuggling, and why am I even doing this video? So HTTP request smuggling is a vulnerability that allowed an attacker to be able to smuggle a request into his request, and then he send it to the back end, and the back end is going to in turn allow the smuggled request or the poison request, okay, in the back end, okay, in the keep alive. That is the main saver of the back end. I'm going to explain all of this very soon. Okay, it's going to abandon that poison request there, and then it's going to affect the request of another user. Okay, so now why am I even talking about this? So this was actually been there for it. A lot of people have talked about it, but as we can see with the reports that have been coming, or we can see that a lot of people don't really understand how this works. They have not been able to exploit it a lot, and then they don't even know how they find it and how they can go around about it. Okay, so I'm going to really explain to you the beginning and everything you need to know about this attack. So this video is going to be shared in, maybe might be divided into 4 parts. It doesn't really depend. So just follow the video. Where it ends is where it ends. Okay, so now let's move into it. Okay, so the first thing is that we are going to move back to when HTTP 1. From HTTP 1.0, and why HTTP 1.1 is so common with this attack. Okay, so with the HTTP 1.0 protocol, okay, so back then it was just a matter of first in first out. What does this actually mean? So meaning that you can see why I'm having here connection close. Okay, meaning that if a request goes in, the connection is going to automatically be closed. Okay, so the back end is going to process the request. Okay, after processing it, it's going to give it back to the client. Okay, and then it's going to send it back to the client before the next request comes in. Okay, so the problem here was when imagine a situation like you have, okay, just doing a single request. Okay, we always have like what we call HTML file, then we have JavaScript, we have CSS, and each and every one of these requests needs to be going in on its own. Okay, because these are separate requests, they are just not one request. And what happens, just imagine a case where you are supposed to send a request, and then the connection is going to be closed. It's going to process the CSS first, and then it's going to give the response back, and then before open the connections again and take in the JavaScript, and then process it and send it back before taking the HTML. Just take the imagine the amount of time that it's going to take. Okay, so it's going to take a lot of time to process all of this. Okay, so that is when the HTTP 1.1 protocol was developed. So this, I'm going to be talking about this HTML thing here later. So let's talk about the HTTP 1.1 protocol now. So with the HTTP 1.1 protocol, there's what we call connection keep alive. So what actually happens is that the connection is always keep alive instead of being closed. It's keep alive in the HTTP 1.1 protocol, meaning that it allowed for every request to just automatically comes. It means that if you're having a JavaScript, CSS, and HTML file, all of them are just going to be implemented at once. They are going to be sent in the to the back end at once, meaning that there's nothing to hold it like connection close. It's not going to close the connection and wait for one to complete before the next comes. It's just going to process all of them at once. Okay, so but in the HTTP 1.1 you can see specify the connection close as well, as you can see right there. But now in the HTTP 1.1, so there's what we call pipelining. So what is this pipelining thing all about? So like in the HTTP 1.0, you could always see first in first out. Okay, so pipelining is still the same concept right there, but you have been advanced. Okay, so you have been there are some advanced additions in it. Okay, so meaning that in this one, if you are sending a request with your IP address, let's say your IP address is 10.10.0.1, and then maybe your port number is 8080. So it's going to move in. I'm sorry, let's fix this. Okay, so this is the first request going in. Then it's going to be going in, combining it with your IP address 10.0.0.1. Maybe it's 8080 again. It's going to respond to it. Okay, so you can see it's going in this your IP address. First it's going to process the request and send it back to your same IP address. But with the pipelining thing right now, they cannot be processing that right now because there are a lot of requests, and with the connections being kept alive, it's not only for one client, so multiple clients can do. I'm sorry, just go back. Okay, so multiple clients are also sending, because the backend server just have just one keep alive. The clients are having their specific keep alive based on their own. Okay, so meaning that it's going to keep alive to each and every user. Okay, so now you can see that the IP address right here, the 10.10.10, is going to go in as the first, and it's going to come out back as the first out. Okay, but in the pipelining thing, when the IP address goes, there are always what we call proxy or load balancer. So what actually happens is that when a request is going in through this load balancer or proxy, the proxy is going to automatically flag the request as one. Okay, to in order to make it to be more rapid. Okay, meaning that it's not going to be waiting for the first in first out thing, and then it's going to send all of the requests at one, but it's going to be specifying it that this one is supposed to be going out first, this one is supposed to be going out second, this one is supposed to be going out third. So it's just going to flag all of them at once, send them in, send them out. Okay, I'm sorry. So now let's discuss how it's handling it. So when this goes in like this, it's just set it to the back end with all of these things right here, like with your IP address and all of the rest. But it doesn't mean that it automatically blocks your IP. Sometimes some web servers accept the IP address, but what the proxy server just does is just going to flag your request as request number one, and then it's going to send it to the server as request one. So the server is going to send back the request, where it's giving back the response to the client or the server. Okay, it's going to flag it against as one again and send it back to the client. Or it's I'm sorry, it's not sending it, it's sending it to the load balancer, and the load balancer will intend turning back and then send it back to the client. Okay, so you can see this I just demonstrated, one in, one out. Okay, so the second one is going to be just second, and then it's going to do the same thing. Okay, but the thing is that they are pipeline, meaning that they are moving in one after another, but at the same time. So you can understand the concept right there. Okay, it's not just first in first out. Okay, so you can see that it's more a little bit advanced, more complicated to really explain as I would have wanted to. Okay, so now let's move. Okay, so now let's move back. So now what actually happened is that in the HTTP 1.1, when a request is sent, like let's say with the HTML thing, so this is the HTML. Okay, so this is the starting of the HTML, this is the end. Okay, it's going to close the connection, and then the next request is going to start right here. Something is going to start here because the connection is going to be closed. After coming, it's a total new request, going to automatically send out everything to this one right here, and then start another request again with this HTML thing, and also having a HTML closing. I'm sorry, you can see it's going to start another one. So this, when the first one goes in, it sends it out, it closes it. The second one's come, it sends out, it closes, and then it will clean everything. And then the problem now with the keep alive thing is that, with the connection keep alive, is that if you are sending it, if everything is in keep alive state, okay, meaning that if this is the first request, it doesn't even wait to process the first request and then before taking the second request. So what you just do is that it's just going to implement everything at once. So it's going to just automatically implement another one, HTML, and the ending. So you can see, and then another request coming in, you just keep doing the same thing. Just going to do it like this again, and then instead move down again before you do the ending, HTML, and everything just keep going in like that, going in like that, going in like that. So what actually is, there's a big problem with this, as you can dictate, because the problem now is the server won't be able to dictate where the request of the first user's request end, where the second request end, where the third request end. Okay, so now, so let's delete this. So now that is when what we call, we'll be talking about it a lot very soon, what we call transfer, so like encoding chunk comes about. Okay, so that's when transfer encoding chunks comes about. So what does transfer encoding chunks actually means? It just means that it should be sending this data maybe in chunk form, or okay, meaning that it's going to be sending either in chunk, which is written in hexadecimal form, and it's going to read the entire chunk and send it once, and then before it sends the second chunk, or it might just be a chunk that is going to be terminating the HTML, where it's just going to indicate that this is where the requests have ended before the next request start. Okay, so let me show you this now in demonstration. So there are actually two types of way that the chunk can be handled at the back end. Okay, so the first one is this tag tag 0 tag tag. Okay, so you can see, so to differentiate this request, so before the next request, when the next request is coming out, it's just going to put a 0, and then it's going to start the next request right here. I'm sorry, so it's going to HTML this and HTML, and then another tag tag 0 tag tag, starting another HTML thing right there. Okay, so you can see the concept. So this is where the chunks come. What the chunk just simply do is step this now. If you see this HTML any that looks like this, you should just simply move two-step down, two-step down, two-step down again, and two-step down, you indicate a 0 to end, show that is the end of the chunk. That is where the requests have ended. The next request again, you need to make it again another two steps down again before you start the next request. Okay, so the second format, so let's talk about the second format of the chunk. So this is the second format that the chunk can still be handled with. So it's going to specify the hexadecimal format of the chunk. Okay, meaning that, let's just say everything here is 11. Okay, so the hexadecimal format right there is supposed to be 11, but you cannot put I'm sorry, you are supposed to put it in the hex form, not 11. If you put 11, it's not going to work, so you need to put it in the hex form. You need to convert. There are a lot of hex converter. I don't know the way for 11, I don't know the hex format, so I'm just going to say that F is the hex format there, and then is that you are supposed to end with a 0. So the back end is going to end with a 0 and move 1 2. So whenever it sees the 0, they automatically knows that this is where the requests have ended, and any request, anything after it should be a new request. Okay, so that is just the understanding behind that. So there's the understanding behind that. And then okay, so there's another situation that we call transfer encoding. Okay, so now let me first of all demonstrate this. So we are just going to move back and talk, excuse, a little bit about them. But okay, so when you see this this and this just simply means this. Okay, let me just show you. Okay, so that just simply means that, okay, so mean that tag or while coverage within 9 feet, coverage within 9 feet, and then zero, coverage within 9 feet, coverage within 9 feet. Okay, so you can see that's as simple as it is. So that's just that. Okay, so now I'm sorry, excuse. So now, what actually happens is that there are two types of chunks. So for you to be able to dictate if what type of uh, chunk encode or what type of request smuggling can you perform. Okay, you must first of all be able to dictate this. Okay, but you cannot dictate it like if you could have not understand this if I never made this video for sure, because Potswaga or the guy James Kitts never really explained this on how, when and how to look for it. Okay, so now on this you are going to see that if you see a situation where you are seeing this and this at the back end, just simply know that it's going to be taking priority. That means the back end is taking priority over the transfer encoding. So normally the front end is supposed to be taking priority over the content length. So you need to look for a way. So that means you are just trying to confuse them. Okay, so you need to try to look for a way where the front end is going to take priority over the content length, whereas the back end take priority over the transfer encoding. Okay, so this is very simple, okay, to understand. But I'm going to as we move on, I'm going to be talking a little bit about it again. So if you see this, then the F right here, so the F right there, and the tag, I'm sorry, tag, you should just simply need to know that what is actually happening here is I'm sorry. So yeah, the front end is taking priority over the transfer encoding chunk, and the back end is taking priority over the content length. So that is just simple as that. That's just what you need to understand. Okay. Okay, so I don't know how I can really explain this anymore, but I'm just going to leave it right here. As we move on, I'm going to talk really more about it so that I can really understand it. Okay, so now let's remove that, and then the next thing is what we call transfer encoding. Transfer encoding. Okay, a transfer encoding, and then we are just going to do something like that. Okay, so on this in this case right here, what is actually happening is that the but that's the fun. It's not really that as he explained, he will explain that both of them are taking priority over the chunk encoding. So I don't really think they are taking priority over the chunk encoding actually. So I'm sorry, I want this right full right here. Both are not really taking priority over the chunk encoding thing right here. But what actually they are taking priority over is that because normally you are supposed to specify the content like if you have to send it in the request. I'm going to be explaining it very soon as we move on. Okay. I'm sorry, excuse. So you can see both are taking part over transfer encoding, but you are supposed to specify a content lane here. So what actually happens is that the proxy server is going to recognize this chunk, and on any request that is being sent with a chunk in the HTTP 1.1 protocol, the chunk is always going to be prioritized and the content layer is going to be ignored. Okay, so what actually happened is that if your backend server was expecting to see a content length only at that same position, and then you send something with a chunk encoding, okay, you send something with a chunk encoding that looks like that, okay, and then you send another transfer encoding chunk. So what actually happens is that there are a lot of transfer encoding. They will compress, deflate, and all of that. So what actually happens is that when the transfer encoding is being seen by the proxy server, it's going to take priority over the transfer encoding chunk, and then the back end is going to recognize this transfer encoding full right there. Yes, it's going to take priority of it, and so it's going to ignore the first one. So it's going to be taking priority over. So it's going to be taking priority over the content length, as we can say, because since it's taking priority over the content length, it's supposed to still give a response based on what the proxy server told it to. So it's never going to give a right response, so it's going to also cause request smuggling. So we are going to talk about it very soon. So in order to dictate this attack, so what if you send a request to the back end? Okay, you don't actually need to send this when you're sending the request. All of these things right here, even with the when you are actually trying to code transfer encoding content length or content length transfer encoding, you don't really need to be sending this. I'm going to be showing you this very soon. So what you actually notice is that instead of it's just going to automatically do something just like that. Okay, so it's just going to move one step down. It's not going to be giving a zero at the back end. So if you just see something, just move something down like that. Just know that you'll be vulnerable to transfer encoding. Okay, So now let's move, and then uh so HTML, just like to put that back. So okay, so there's also one which is also vulnerable to what we call content length. Instead of using the transfer encoding, but that there was no way to dictate that. I'll be very honest with you. So this is the content length, specifying two content length. So you might specify a content length of 8, and then another content length again of, let's just say, another content length of mhm, let's say 7. Yeah, 7. So what actually happens is that you are sending two content lengths, right? And then the back end is going to be doing something really strange, because the back end at the proxy might take, the proxy might recognize the 7, okay, while the back end recognizes the 8. But what actually happens is that the back end is always supposed to hear from the proxy server. So since the proxy server just sent the 7, it's going to only respond to that 7 byte, and then it's going to allow the 1 byte hanging around. So it's going to cause what we call HTTP request smuggling. And for you to know if it's vulnerable to content length, you are not going to see anything like this, but it's just going to remain like that, meaning that it's waiting that another request should start right here. Okay, you can see it. So it's always going to take care, remove all of this before taking the other requests as in the HTTP 1.0 protocol. So I hope you have understand this. So let's just move into some demonstration. So now actually develop a bash script so that we can learn from it. So the first thing is a post request. So you can see there's nothing here like the transfer encoding chunk, but we just have the connection keep alive here, which connection keep alive, no transfer encoding chunk, no content length, and then this just simply mean convert from Unix to DOS. I don't know, some of you might know about this, but let me just try to explain it a little bit. Sorry, so this simply means this. Okay, so convert from Unix to DOS. You can also convert from DOS to Unix. Okay, so converting from Unix to DOS just simply mean this. So normally the Unix environment always had this. Okay, the environment always have that. Okay, as a line break, meaning that that just simply means what we were doing. So if you're having something, just simply like, let's move up here. That just simply mean this. Okay, let's do that back, then move back. Okay, so it just simply mean that you want it to convert from this simple thing here to this one here, which the HTTP 1.1 protocol or the HTTP protocols in general understand. All the versions understand this form of coverage return line feed. Understand the line feed, but the Unix environment just understand the line feed. I don't know if uh, Windows environment also understand this, but I'm pretty sure they understand it as well. Okay, so let's just write just simply here. So now you can see I'm sending a request to facebook.com over OpenSSL, and then S client that, and then web.facebook.com. So now let's just send a request on it and see. So I'm saving that. Let's go to the terminal and send a request on it. I'm sorry. So this is like a directory where my the directory of my SD card where the script is found. So let me just run the script so you can see there's it bash smuggler.sh. Let's run that. So let's just move on and try what is actually happening. So this is what actually happens when you send a request. So you can see the process is taking place behind the request. So you can see this is how the server generate the request. So you can see these are the begin certificates. So these are the amount of requests that you as a client are sending. The server is going to intend return to it back. Okay, so it's going to initialize a handshake. Then you can see this a handshake is going to generate a session for that particular handshake. And then so that you can be able to exchange information. So I think I understand. So you can see this is the Facebook thing. So you can see transfer encoding chunk is taking priority over the transfer encoding chunk at the back end. The connection is set to keep alive right here. And then you can see, so this is taking part. Okay, so this web server can be vulnerable to what we call uh, content length transfer encoding. Okay, so like I told you earlier, so you can see it's having the hexaform. So this is the first hex. So this hex up, I'm sorry. So this hex here, you with this entire thing right here, and it comes right down. then there are supposed to be more and more and more and more and more of them. Okay, so now let's see. So you can see this is what I was talking about. So you can see ended it with a zero. That is why the backend understand it ended it with zero, and after a zero you just simply move again two as we said, one two. Okay, so you can see the connection is being kept alive, meaning that you have initialized the connection. You don't need to keep on initializing the connection each and every time again. So it's just going to keep the connection alive for a specific amount of time that has been specified by the server or the client. Okay, so let's see what if we do this now. We set the connection and then we convert it. Like I told you, the HTTP 1.1 also support the connection close thing. So let's set it to close and run it again and see what just happened. We'll see what will happen. Okay, so you can see automatically close the connection after the zero. You just move one two, it closes it automatically. So you can see the difference right now. So keep alive just simply mean keep it, wait for some other connections to come. It mean that you are just going to be sending a request. Since I just send only one request here, so why only give me one response. So but I can specify it and send about 5 requests at the same time. I'm going to receive the response at the same time as well. So since it's using the pipelining thing. Yeah. Okay, so let's turn this back to keep alive, and then the next thing is, so the first time this is for what we call uh so the first request just sent is can only be vulnerable to what we call content length transfer encoding, or what we call CLTA. So now let's change it back to keep alive, and then the next our next target will be on, I'm sorry. Okay, so staging login dot newrelic.com. Gosh, I'm sorry, mess up everything. So it should be staging. Let's remove this and paste it right there. Okay, so I'm just going to save it, and let's go and run it and see if which type of request looking can the web server be vulnerable to. So let's send it. Okay, so like I told you, just seeing a single tag just simply make can be vulnerable to what we call I'm sorry, it can be vulnerable to what we call transfer encoding. And let's move on and see something right here. Right here, you are not going to find anything like transfer encoding chunk. So it means that 404 not found thing, no problem. So you can really see that this is how it is. So this saver can only be vulnerable to transfer encoding thing. So that's how it is. There's nothing there like transfer encoding. It's only having the content lane as well. The saver is having the content lane, as you can see content lane right up there. Okay, let's just close that, and it's still having the connection keep alive. So it's still waiting for another connection to come in, but you just simply step it down. The next request is going to start at the bottom right there. Okay, so now let's move to the next one. So the next one will be zomato.com. Okay, let's move on. So the thing is that if you don't think that when people tell you that you can update to HTTP 2.2, don't think that you are going to be safe, because actually you can still downgrade this. No matter that you will not be able to affect some other users, but you can still be able to bypass some firewall rules. Okay, so always try to fix the book. Don't say you are updating to HTTP 2 and then you are secure, because your HTTP version can still be downgraded by the hacker to HTTP 1.1, and then you're still going to perform the attack. Though you cannot attack some other users, but it's going to be able to bypass some firewall rules which you don't want to. Okay, so now it's zomato.com. So let's see the type uh, of smoke you can be vulnerable to. Okay, this is still vulnerable to the same attack. Okay, so you can see this is still vulnerable. So you can see this to confirm to you that even though a server can be vulnerable to what we call transfer recording, this it can still be changed, because like in this most of the time with this 301 move permanently thing, you always try to convert it back to be using the transfer recording thing. So meaning that you can say attack it based on this guy. So you can see www.zomato.com and then on port 443. No problem. It's really fun to see a silver responding with the 443 at the back of it. Okay, it's very uncommon to see that most of the times. Okay, so I just think let me just look for something that can, I don't know why, because I'm looking for a particular role that can be able to give us I'm sorry, the other form of transfer encoding chunk. There's a content length transfer encoding thing. So let me just, okay, tips that area was having that area.com. Tipstar area.com. Oof. Let's hit on that. Yeah, we got it. Okay, so you can see it's having but this tick tick zero tick tick. Okay, so in this case right here, it can only be for what we call I'm sorry, that's content length transfer encoding. Okay, so I've already teach you all the types of things that can be performed on this, so just stay in touch. In the next video I'm going to be showing you the exploitations on each and every one of these that we have just demonstrated here. Thanks for watching, and I would like you to leave a like on it before you leave.